Friends, welcome to the channel God is Science, or Science is God. I am Sanjay Dosaj, today here with a new and complex topic on the complexity of space-time. From the very beginning on this channel, I've been saying that the universe itself provides evidences to reveal itself. The requirement, however, is of having an open mind that is ready to visualize and accept things with a new perspective. If you have any questions left lingering in your mind after watching the video, feel free to ask in the comments section. I will try to answer them to your satisfaction. If you are a researcher or an expert professional in the field of astronomy and working in the field, I will be pleased to discuss with you, so please feel free to access the comments section. Please like and subscribe the channel before we begin today's video, and if you like the videos, please don't forget to share on all platforms. So now let's begin with today's video without any further delay. Have you ever pondered the mystery of what happens when a photon, a particle with no mass, ventures into the abyss of a black hole? It's a question that challenges our understanding of the universe and the laws of physics. To unravel this mystery, we need to delve into the interplay of forces. From another video on formation of a black hole, we know that a black hole is a whirlpool and it rotates at the speed light. There are already evidence pouring in this regard, and the spaghettified matter taking a circular path around the accretion disk is the evidence. An object will take a straight path towards the center of gravity in the absence of any other force. Now, in the black hole rotating at this speed, let us analyze the active forces. Consider the centripetal force, which is directly proportional to mass and the square of angular velocity and inversely proportional to the radius. For instance, if we take a hypothetical mass of 1 kilogram, an angular velocity of 10 meters per second, and a radius of 1 meter, we find that the centripetal force equals 100 newtons. Now, imagine if we increase the velocity tenfold to 100 meters per second, while keeping all other parameters the same. The force multiplies 100 times to 10,000 newtons. If we increase the mass, the force also multiplies correspondingly. Thus, if we push the parameters to cosmic proportions with velocity nearing the speed of light and mass equivalent to a celestial body, the force becomes immense, enough to obliterate any object. But what happens when we reduce the mass to zero, as is the case with a photon? The centripetal force becomes nil, implying that neither gravity nor centripetal force should affect a massless object. So why can't a photon escape from a black hole? The answer lies in the very fabric of the universe, space and time. According to the theory of relativity, motion is relative. For example, if you're standing by a road and a car passes by, its speed is relative to you and other stationary objects. If you start traveling at the same speed as the car becomes stationary relative to you. Now imagine if time is the other car. If you travel at the speed of light, time becomes stationary relative to you. Similarly, when the photon travels in the rotating space-time within the black hole, it comes to be stationary with respect to space-time. Thus, we can conclude that time is a physical entity traveling at the speed of light, and together with space forms a superfluid known as space-time. In the context of a photon at the speed of light, time becomes stationary, implying the time traveled is zero. Consequently, the distance traveled by the photon is also zero. This viewpoint unifies time with space. Thus, a photon traveling at the speed of light becomes stationary relative to space-time within a black hole rotating at the speed of light. In sum, a photon trapped in a black hole provides compelling evidence for the existence of space-time as a physical entity. The interaction of photons and black holes challenges our understanding of the universe and the laws of physics, pushing us to redefine our understanding of fundamental concepts such as force, mass, speed, and even time and space. It's a fascinating journey into the unknown, a testament to the endless wonder and complexity of our universe.